Hi grade 9s. So the next thing we're going to discuss is similar polygons. So a similar polygon are reductions or enlargements of each other. So for example, I've given you a shape here. Let's redraw it. So in this one, point B is 2 away. Point A is 4 down and 1 over. 1, 2, 3, 4. Point C is 1, 2, 3, 4, 5 down and 1 in. And point D is 3 over and 1 up. So then we connect. So this is smaller, so this is the reduction. So let's label it. So this is going to be A prime, B prime, C prime, and D prime. Okay, now let's look at our enlargement. Okay, so we're going to do the same thing. Our grid is just a different size. Okay, so we've got A double prime, B double prime, C double prime, and D double prime. So this is our enlargement. Okay. Now, one thing you should notice about our two new diagrams is while the lengths have changed here, these interior angles have not, and that's going to be key moving forward. So our original drawing, the reduction and the enlargement, are similar polygons because the side ratios are the same. So if we were to measure the side lengths of all of those polygons, we would see that the ratio of AB to AB prime is going to be the same ratio as BC, BC prime, etc., etc. Okay, so the ratios are going to be the same. Then the interior angles are also going to be the same. So angle A is going to be equal to the same angle in A prime and A prime prime. Okay, same thing with angle B, C, and D. So we can use these two principles to prove if a polygon is similar and find unknown dimensions of figures which are similar. So, are these two triangles similar? So, I had to change the scale a bit, but the measurements are correct. So, let's look at side ratios. Let's compare AB to AB prime. Okay? So, AB is going to be 58.31 to 75.55. So that is going to be a ratio of 0.77. Okay, now let's look at AC and AC prime. So here, that's going to be 70.71 to 91.61. So let's compare. 70.71 divided by 91.61. We get 0.77. All right, so we're in good shape. These two are equal. Can we stop here? No, we have to check BC. So let's check BC and BC prime. Okay, so that's going to be 80 over 103.65. So once again, we have a ratio of 0.77, so they are similar. Okay, so another way we could say they were similar is if we were to take a protractor and measure each angle here. Okay, but because we know all the side lengths, we know that the two triangles are similar. If I just gave you angles, then you could compare the angle ratios, or if the angles are the same. So let's move on to another example. The following rectangles are similar, so we know they're similar. Now we want to know the dimension represented here. What is this? So you can't simply measure because the rectangles are not always going to be drawn to scale. And besides, because we're working with computers, it's very difficult to get accurate measurements. So what we're going to do is we're going to look at these two. Okay? Now, my known lengths, so I've got my length, so I've got length and then length prime. Okay, then I've got my width and width prime. Okay, so my primes are on the bottom, my originals are on the top. Okay, so now my original length was 70 millimeters and my length prime is 104.31 millimeters. Okay, now my original width is 30 millimeters and we want to know what x is. So again, we've got a proportional problem, so let's flip it. So it's going to be 104.31 over 70 equals x over 30. Okay, so now we're going to multiply both sides by 30. So 30 times 104.31. And then we're going to divide it by 70. So here we get a length of 44.70 equals x, and our units are millimeters. So we've just found the unknown side. So I'm just going to erase that. So this is our last example for this video. So we want to find the unknown values of x and y. So the two diagrams are not to scale, but they are similar. So we can use our ratios here. So what we're going to do is we are going to pick one of our knowns and an unknown. So first, we know that h and f prime are similar. So you can either put your primes on the top or your originals on the top, doesn't matter. To save a step, we're actually going to put primes on the top. So we're going to go x prime over the corresponding side, which is 72.11. And then we're going to take this one, so it's our prime, 68.72 over the corresponding side. Okay, so now we can go ahead and solve. So we're just going to multiply both sides by 72.11. That cancels, so we've got x is equal to 110.81. Okay, and that units are millimeters on that. So does that make sense? Well, here's our original, here's our new. It's an enlargement, so this has to be bigger than this. Okay, now we would do the same thing for y. So we've got y prime, the corresponding side is 80. And then we've got our, y, the corresponding side is 80. And then we've got our 68.72 over 44.72. Okay, so now we're going to multiply both sides by 80. That will cancel. And we are left with 122.93. Okay, and our units are millimeters. So here we're able to use our known sides to figure out our unknown. And we can only do this when the shapes are similar. So here we have our textbook assignment. So try a few of those questions out and see how you guys do.